All right, guys, so for the majority of our 12.6b video, I'm just going to be showing you this unit circle and filling in the unit circle. It's a super, super important part of being able to understand a lot of the trig that you guys are working with. So first thing I'm going to do is go around the inside. We're going to fill in the degrees. So the degrees should be kind of the easiest part of this unit circle. So this is, remember, 0 degrees, 30, 45, 60, 90, 120, 135, all right, and then it ends at 360 degrees. All right, so the degrees we've seen before. I think you guys even did these in geometry. You should know these angle measurements all the way around the unit circle. We should at least be comfortable with the like 0, 90, 180, 270, and then you can fill them in the middle with like the 45-degree gaps, the 30-degree gaps. All right, so the next thing I want to show you is where we come up with our radians. Remember, we still start with 0. So I'm just going to do some quick calculations because I know we filled these out before, but I just want to show you exactly where they're coming from. So we're going to first jump all the way around the unit circle in 45-degree measures. All right, so let's first take that 45-degree measure. And remember, to convert it into radians, you multiply by pi over 180. All right, so this 45 and 180 are actually both multiples of 45. So if I reduce it down by 45, this leaves me with 1, and this divided by 45 is 4. So this is just pi over 4. So that means that this measurement right here is the same as pi over 4. So what I can do is I can jump around in these 45-degree increments, because here 45 plus 45 is 90. Which means if I go radians, pi over 4 plus pi over 4 should give me whatever this is. So if I just tack on another pi over 4, this would be 2 pi over 4. But 2 over 4 reduces down. So instead of 2 pi over 4, it reduces down to just 1 pi over 2. Okay, and then jump to the next one. So this is 1 pi over 4. This is 2 pi over 4. That would make this 3 pi over 4, which does not reduce. And that would make this 4 pi over 4. But of course the 4 and 4 would reduce down to just pi. And then the next jump would be 5 pi over 4. And that does not reduce. This would be 6 pi over 4. And 6 and 4 are both even, so we can reduce that down to 3 pi over 2. 6 pi over 4 jumps to 7 pi over 4. And then 8 pi over 4, which just reduces down to 2 pi, and that's where our cycle ends. So that's jumping around in pi over 4 increments, which is the same as 45 degrees. So now let's jump around in the 30-degree increments. So 30 degrees, if we multiply that by pi over 180, the 30 and the 180 are both multiples of 30, so this reduces down to 1, and this reduces down to 6. So that means we're jumping by pi over 6s. So this first one would be pi over 6. 1 pi over 6, this would be 2 pi over 6, but 2 pi over 6 reduces down to 1 pi over 3. 2 pi over 6 jumps to 3 pi over 6, which reduces down. Jumps to 4 pi over 6, which reduces down. Jumps to 5 pi over 6, which does not. That makes this 6 pi over 6, 7 pi over 6, 8 pi over 6, which reduces down. 9 pi over 6, which we've already reduced down, 10 pi over 6, which reduces down, and finally 11 pi over 6, which does not. And that would make this 12 pi over 6. So those are my degrees, my radians. You should be comfortable with those and know where they are, because this reference angle idea that we did earlier in 12.3 is going to be super important to helping us figure out what these ordered pairs are all the way around the unit circle. So first thing I want you to start with, remember this is a unit circle. We have this written up here that this is in fact a unit circle, which means the radius is 1. So if I jump from here to here, that's just 1 unit. If I jump from here to here, that's 1 unit. So remember, we are considering this to be the origin. Starting right in the center, this would be the origin 0, 0. So I want to figure out relative to the origin, what would all these other points be all the way around. So if I go 1 unit over, this would be the coordinate point 1, 0. Okay, if I go 1 unit up, this would be 0, 1. If I go 1 unit left, this would be negative 1, 0. 1 unit down would be 0, negative 1. All right, so those are the easy ones. That's just one, up, down, left, and right. The diagonal ones are the ones that get a little bit tricky. All right, so let's fill in these three values right here. All right, so if we are looking at this measurement, remember, I'm going to flip you back to the previous page, something that we did in 12.6a. This right here tells you that if you're sitting on a unit circle, the xy coordinate points are just the cosine and sine of that angle. So what we did yesterday was we knew this, and we used that to figure out what the cosine and sine were, but now we're in a position where we know the cosine and sine, or we did previously. They're in some previous sections here. So if we know what the cosine and sine are, we can jump back and fill in what the coordinate points would be. So let's look what the first one we're looking at. First thing is we want the coordinate points at 30 degrees, which means we want to know the cosine of 30 degrees and the sine of 30 degrees. Well, we had that a while back. So I'm going to flip you guys back all the way to this little chart. So this was in your 12.3 notes. We had this little chart right here. So we know the cosine of 30 degrees and we know the sine of 30 degrees. So we can keep referencing back to this chart. So I'm going to make sure I keep my finger right here. So the cosine of 30 degrees was root 3 over 2. So that makes this root 3 over 2. And the sine of 30 degrees was 1/2. Okay, so we can just fill those in pretty easily. So now let's look at the next one. Next one is 45 degrees. So we've got the cosine of 45 degrees, and we have the sine of 45 degrees. And we can just fill those right in. So the cosine was root 2 over 2. The sine was also root 2 over 2. And then finally, we've got the 60 degrees right here. So 60, we had the cosine of 60 degrees is 1/2. Sine of 60 degrees is root 3 over 2. So you can fill those in as well. Okay, so here's what we have so far. We have the four easy angles right here, and then we also have the first quadrant. Now this is where the reference angle thing comes in. So if we know all the coordinate points in these four quadrants that we have, in the first quadrant, all of our coordinate points are positive. The x values are positive, the y values are positive, every coordinate point is completely positive. When we move left into the second quadrant, our x values are now negative, but my y values remain positive. When you move down into the third quadrant, the x values are still negative, but now the y values turn negative. And when we move back over to the right, the x values turn back to being positive, but my y values are now negative because we're below the x-axis. So these are your four coordinate points. So take a look at your reference angles. So this 30 degrees right here, this one right here has a 30-degree reference angle. So if you look at this coordinate point compared to this coordinate point, they have the exact same height, which means they're going to have the exact same y value. So if this is a y value of 1/2, then this is also a y value of 1/2. And you can do the exact same thing with this ordered pair compared to this ordered pair. They have the same y value, which means this y value is root 2 over 2. Same thing with this point compared to this point. They would have the same y value of root 3 over 2. Okay, so we can do that. Now, let's look at x values. If we compare this one, this angle right here also has a reference angle of 30 degrees. And look at their x values. They're right in line with each other. So whatever this x value is, this x value is the same. So this x value would be root 3 over 2. We can also compare this 45-degree angle to this angle, which has a 45-degree reference angle, and these x values would match up. So you've got that. And finally, this 60-degree angle compared to this 300-degree angle, which has a reference angle of 60, these x-coordinates would be the same. So this would be 1/2. All right, and we can start to transition this all the way around the unit circle. So here's the next thing that we're going to see. Now look at this y value compared to this y value. These ones, they're the same distance away, but this is a positive y value, this is a negative y value. So when this is positive 1/2, that would make this negative 1/2. And since this is positive root 2 over 2, that would make this negative root 2 over 2. And one more, since this is positive root 3 over 2, that would make this negative root 3 over 2. And you can see all the coordinate points. Positive, negative, that's what we have right here. These are all positive, positive. Now these ones are negative, positive, which means if you compare this point to this point, these distances right here are the same, but this would be a positive x value, whereas this would be a negative x value. So you can match these x values up with these ones. They would just be negative. So this is negative root 3 over 2, this is negative root 2 over 2, and this is negative 1/2. And finally, we can fill this one in. This one's negative for both of them. So if we look at these complete points, like this has a 30-degree reference angle, this one has a 30-degree reference angle. So these are going to have opposite x values and opposite y values. Or you could say that like these two x values match, which you can see right here, and these two y values match, which you can see right here. Either way. All right, so this point is going to become completely negative right here. Negative root 2 over 2, negative root 2 over 2. Or again, you could say that this point and this point have the same x value, and it has the same y value as this point right here. And last one, same x value as this point, negative 1/2. Same y value as this point, negative root 3 over 2. Or you can consider it to be the total opposite of its reference angle, which is right here. So lots and lots of different ways that we kind of create what all of these ordered pairs are. The important part is that we know these ordered pairs, and we can use that anywhere around the unit circle. So you guys are going to be answering questions like this in your homework. So cosine of 45 degrees, we find 45 degrees, and we know that all of the ordered pairs are just cosine and then sine. So the cosine of 45 degrees must be root 2 over 2. And we can do the same thing for 150. If we find 150, if we want to know the cosine of 150, it's just the x-coordinate, so negative root 3 over 2. And this brings into mind some of the 12.3 stuff that we were doing with the reference angles. We talked about how normally, like in 12.1, everything was positive. All the cosines, sines, tangents, all that was positive because we were just dealing within that first quadrant. But now that we expand ourselves into the first quadrant, cosine and sine are going to start becoming negative, depending upon which quadrant we're in. So let's look at this last one, 270. 270 is right here. The sine is now the y value. So the y value here is negative 1. So the sine of 270 is negative 1. So we've got all these values, and you notice that the cycles are going to repeat every 360 degrees. So like all the way around once is 360 degrees, but if you start to repeat these values again, this would be also 390 degrees. Which would make this 405 degrees, and it would make this 420 degrees. And it just repeats itself over and over and over again. So the values of sine and the values of cosine are also known as periodic functions. And so if we look at just this last little bit that I want to show you guys here, we end up drawing exactly what these sketches look like, and it looks really similar to this pedal graph that we made ourselves the other day. So these are our sine values and our cosine values. It's essentially just plotting the degrees versus the sine or the cosine that we come up with. So we can come up with these values just really quickly. So the cosine of negative 3 pi over 4, so we know where that's going to be. If we go back, this is back pi over 2, and then this would be back pi over 4. So we want this position right here. So we want to know what that ordered pair would be. So this ordered pair, any pi over 4 family member, remember it's all root 2 over 2. So we know it's going to be root 2 over 2. And then we're in the third quadrant. In the third quadrant, the x value is negative, and the cosine is always the x value. So we know that this is going to be negative root 2 over 2. All right, so let me show you just for reference. So back this angle right here, same position as this one. The cosine you can see is negative root 2 over 2. Let's try one more. Sine of 420 degrees. So we go all the way around to 360. And then that leaves us with a remaining 60 degrees. So right there. So same as 60 degrees. So we know it's the same as this. And then the sine of 60 degrees, let's look back at that unit circle. Here's 60 degrees. The sine would be root 3 over 2, and it's going to be a positive root 3 over 2 because it's in the first quadrant. So we're going to get a lot of practice with these values. I'm going to show you guys some tricks that you should be able to just quickly come up with sine and cosine for 30 and 45 and 60, and then you'll be able to transfer them all the way around the rest of the unit circle.